So this is example number 2 on determining the primary protein sequence through partial hydrolysis. So let's look at this one. It's very similar to the previous video, just some different fragments and some different information that's presented. So in this one, a decapeptide undergoes partial hydrolysis. So again, we've taken this protein and we've broken it up into chunks. And the chunks are listed below. This again is going to give you 8 different chunks, and here they are: 1, 2, 3, 4, 5, 6, 7, and 8. It says the fragments are formed and listed below. Edmonds reagent gives PTH glycine. So PTH glycine, again, Edmonds, it's telling us the very first amino acid in the sequence, and that way we can work from that point on to determine the rest of the sequence. And that's what the question is after. Determine the primary sequence. So just like the game of Hangman, deca means 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's how I always like to start, because in the upcoming examples you're going to see these get a little bit more complicated. Yes, I said more complicated than what they already are. So the Edmonds reagent gives glycine. So I'm going to go through and I'm going to find glycine. And here I find glycine, GLY, and I don't really find it anywhere else. I take a look, GLU, and then here's a GLU, there's a GLU. So that's really the only glycine that's here. So GLY, I know, is in the beginning. Now, because this is the only GLY in the fragment pattern, then I know that what comes next has to be ARG, which is arginine. Okay, so I know that that has to happen. So now I'm going to find arginine. If I can find arginine somewhere else, then maybe this will give me an idea of what's going to happen. So I need to find ARG. So I go through and I find ARG, and ARG is right there. And then I'll try to maybe find some other ARG units, and I can't really find any. So I know that ARG, these two are now going to be in question, right? So I've got tryptophan and alanine. So a TRP and an ALA. And I know that these have to go in one of these two spots. I just don't really know which one yet. And the reason is because it's very unclear. Glycine we're starting off with, GLY in the beginning. I know that the only other choice that has to go in the second one is arginine, ARG, so that has to go there. I know that. This is the only fragment that has arginine in it, and that includes the TRP and the ALA. The ALA, of course, is alanine, and the TRP is, of course, tryptophan. So these two, I don't really know for sure which one goes where yet, so I'm going to have to kind of look at the upcoming fragments to see what's there. So let's see if we can find a tryptophan fragment. And here's tryptophan, and it looks like it's coming with alanine. So yeah, it looks like they're coming together. I just don't really know what order yet. So arginine has been taken care of. I know that tryptophan and alanine are going to come next, so I can get rid of those to clean that up. Okay, is there another tryptophan somewhere? Let's try to find a fragment with tryptophan. So I go through, I try to find tryptophan. This is the one that was in question. This is what started this whole mess. And then I go through and try to find another tryptophan, and I don't. Okay, what about alanine? Is there another fragment with alanine? Maybe I can get a better picture here. So I go through, and it looks like, yeah, I get a fragment with alanine and GLU. Now, do you remember what GLU stands for? Yeah, GLU stands for glutamate. So I get alanine and glutamate there. This is the fragment that started this whole mess, so there's another alanine. It looks like here's another alanine, glutamate and leucine. So it looks like, to me, if I look at the fragmentation pattern, tryptophan and alanine are coming together. and then alanine is coming along with other stuff. So that probably means that tryptophan is going to come next. There's really no other possibilities that I could have with tryptophan. It's tryptophan and then alanine. So this gives me an order basically of what comes first. And then, now that I've taken care of alanine and tryptophan, I then can look at the other fragments that have alanine with them. It looks like alanine also has GLU, so glutamate is there, so that takes care of those. Well, here's glutamate, and there's alanine that's already been written. It looks like the next one is leucine, so there's that one. And then I need to find leucine, and I go through, here's a leucine fragment, and then I try to find a leucine fragment somewhere else, and I don't. So I know at least leucine is there. Look, glutamate is already taken care of, GLU, so that one's already taken care of. Then I've got this methionine and proline. So on these two spots, I've got another question here. Methionine and proline is probably going to go in one of these two spots. I just don't know which one. I've got to figure it out. What comes next is proline and valine. So it looks like valine will come along with proline for the ride. The only way that that would work is if proline happens here and valine happens there. That way they can come off together. So proline and valine. That fixes my problem here with methionine. So methionine is now taken care of. Valine, proline, and then finally our ASP happens at the very end. So ASP, do you remember what that one stood for? Yeah, that's aspartate or aspartic acid, depending on the pH of the solution. So this is another example of a deca peptide that has been sequenced by using Edmonds only and then taking a look at the other fragmentation patterns. To double check yourself with these problems, just make sure that you can get the fragments that are stated with nothing else that can come along. So for instance, can we get an alanine and tryptophan to come off together? And the answer is yes, right here they are. So there's the fragment that caused that one. Can we get a valine, proline, and aspartate to come off together? And the answer is yes. Here it is, PROVALASP. So that one checks out. Can we get a proline and valine to come off side by side? Well, yeah, we can. Here it is. Proline and valine can come off together and form a fragment. Okay, just do that for the rest of them. What about ALA and GLU? So ALA and GLU coming off together as a chunk. What about fragment 5? TRP, ALA, and ARG. So TRP, ALA, and ARG. So there is that chunk that came off. What about ARG and GLY? Well, ARG and GLY, first two in the list. There we go. Finally, the glutamate. I can't really read what that one was. It looks like I've scribbled that out one. I think that's alanine and leucine. So glutamate, alanine, and leucine. There is the fragment that happens with that chunk. They're coming off together. And then finally methionine, proline. Yeah, there's those two, leucine and glutamate. So there is the fragment that's coming off of that one. So you can go through, double check, make sure that you can get these fragmentation patterns like you're supposed to, because again, they're coming off in chunks, they're coming off in groups. Once you get your protein sequence laid out, you want to make sure that those chunks and groups are represented with the fragmentation pattern. Okay, what if I wanted one-letter abbreviations? Glycine is a G, arginine is an R, tryptophan was that W, alanine is the A, GLUT, GLU, do you remember what that one was? Test yourself. Yeah, that's one of those weird ones. So that is a E for glutamate. The next one is leucine. Leucine is an L. Then methionine is an M. Proline is a P. Valine is a V. And ASP, aspartate. That's another weird one. Do you remember what that one was? Yeah, hopefully you guessed it correctly. That's a D. So there is the primary protein sequence or primary amino acid sequence for this protein. And I can do one letter abbreviations, and that is the protein that I have came up with. So there's another example problem. You're going to see these on your homework, you're going to see these on the quizzes, and you're going to see these on the test. So my advice is to go through, make sure you read this section of the text, go to the end of the chapter. They've got a couple of more of examples of these that you can work through, and look at the study guide that's going to be posted, because those will also give you some examples and answers to the book questions, because you don't have access to those. So my advice, practice these, because they are going to be point whoppers on the test. So these are the problems that you do not want to miss. So now if I take a look at the structure of this test, quite a bit of points are going to come from drawing the structures of the amino acids. And then the next part or chunk of the test will come from these types of problems. What kind of sequencing problems are we going to be seeing? And these are two examples of those sequencing problems. There's going to be more, of course, that we'll continue to talk about in upcoming videos, but this will be a start for the sequence problems. So we're still talking about primary sequence. We're just working through some examples. We've talked about Edmonds. We've talked about carboxypeptidase. Well, there's going to be some others that are going to be involved as well, and that's what the upcoming videos will target and focus.